We have a very close relationship with Saturn. Better to say, we have a closer relation with Saturn's rings. As you can all see, on Earth, there is water everywhere. The oceans have helped the Earth to develop life. And that life has been thriving here for years, even after some mass extinction events. But Saturn is a gas giant. We have not yet been able to know if Saturn has a proper surface or not. Scientists think Saturn, as a gas giant, doesn't have a true surface. The planet is mostly swirling gases and liquids deeper down. But the rings of Saturn are made of water ice. Yes, it is the secret of Saturn's rings' brightness. In this episode of Wonders of the Solar System, we will learn about the first wonder, Saturn's ring. So keep on watching till the end. Saturn's rings were discovered almost 400 years ago by Galileo. In the year 1610, while looking into space through a telescope that he made, Galileo found the beautiful rings of Saturn. The rings are thought to be made from pieces of comets, asteroids, or shattered moons that broke up before they reached the planet, torn apart by Saturn's powerful gravity. They are composed of billions of tiny ice and rock pieces that have been covered with various elements, such as dust, to form their structure. Particle sizes range from dust-sized ice, to boulders the size of an entire house. A few particles are the size of mountains, but the most are far smaller. Looked from above, they're mainly white, and each one circles Saturn at its own unique speed. Saturn's ring system extends up to 175,000 miles or 282,000 kilometers from the planet. But despite its vast distance from the planet, Saturn's rings have an average vertical height of around 30 feet, 10 meters, in its major rings, which is roughly as high as a 3-story building. The Cassini division, which separates rings A and B, measures 2,920 miles, 4,700 kilometers, in breadth. A, B, and C are the 3 major rings. More recently discovered rings include D, E, F and G. Saturn's inner rings have been the subject of 2 major theories. Some believe that the rings were once a Saturnian moon called Veritas, which was torn apart by the pressures of the tidal forces of Saturn. This idea was first suggested by Édouard Roche in the 19th century. The rings are made up of debris from a moon 400 to 600 kilometers in diameter, somewhat larger than Mimas, according to a more conventional form of the disrupted moon idea. The last time there were collisions large enough to disturb a moon of that size was 4 billion years ago, during the late heavy bombardment. A whirlpool of gas and dust was drawn in by gravity, as the rest of the solar system was forming 4.5 billion years ago. And that became Saturn. As Saturn moved out into the outer solar system, it took around 4 billion years for it to settle into its current location. Saturn, like Jupiter, is mostly composed of hydrogen and helium, the same elements that make up the Sun. A disk around Saturn was initially described by Christian Huygens, back in 1655. After that, Saturn's rings were discovered by Giovanni Domenico Cassini in 1675. The Cassini division is the biggest of these gaps. In the 18th century, Pierre-Simon Laplace proposed that Saturn's rings are made up of a succession of small ringlets. This suggests that Saturn's rings must be made of many tiny particles orbiting Saturn in their own orbits. In 1859, James Clerk Maxwell proved that non-uniform solid ringlets or a continuous fluid ring would similarly not be stable. Later observations proved Maxwell's analysis was correct. The age of Saturn's rings has been estimated in a variety of ways. According to one theory, they may date back to the creation of Saturn itself. They may be between 10 million and 100 million years old based on Cassini's findings, but it's possible that they're considerably younger than that. On the basis of a fresh, low-mass estimate, dynamical evolution modeling and observations of interplanetary dust flux, this latest origin scenario calculates the rate of ring darkening over time. So, yes, Saturn is slowly losing its ring. For this reason, they would have been more enormous in the past. Mass, alone, is not particularly informative, as high-mass rings that formed early in the solar system's history would have evolved to a mass near to that observed by today. These rings may be extinct in 300 million years if current rates of depletion are maintained. It does not matter how much we want to run on Saturn's ring. We can't. The ring, as we discussed earlier, is made of particle sizes range from dust-sized ice to boulders the size of an entire house. And they are too far away from each other for a human like us to run. We can though land on a giant boulder-sized icy rock and run there. During the summer of 2004, the Cassini spacecraft reached Saturn. It studied Saturn, its rings, and its moons in greater detail than the preceding missions. HEXAGON was a probe that Cassini dropped into the atmosphere of Saturn's moon Titan. Despite the fact that we have never seen the surface of this alien globe, HEXAGON sent back a wealth of data and photographs. Discoveries made by Cassini and HEXAGON are many. Cassini's mission concluded in September 2017 with a scheduled dive into Saturn's atmosphere. So tell me, do you want to dive on Saturn or walk on its ring? Or maybe just keep on watching the beautiful wonder of our solar system, Saturn and its rings?